part, we can get these guys set up now. If we're starting to understand, if we're prepared to take a little quiz tomorrow on all of these. All right, we can hopefully do these now. Is that a hand up? Not yet, John. Good call. Thank you. All right, so no. So now I am presenting. So those at home, if I didn't see this then, numbers 1 and 2 on this page, don't necessarily worry about. These are ones where you got to set up multiple equations, and we're not necessarily overly concerned about those at this moment. So we're going to start with number 3. This should just be the next couple pages in your packet. And then also, since I wasn't sharing at home, this is what I showed people a minute ago. The homework tonight, make sure you put in the one that says May 3rd, that's today's date. And then May 4th is going to be the one that we start with right now. And then again, whatever you don't get done, you're going to upload that for tomorrow. But that's optional. All right, so it says a plane takes off from a field and rises at an angle of 11 degrees with the horizontal. Find to the nearest foot the height of the plane after it has traveled a horizontal distance of 1,000 feet. So we'll draw this one together. First one, since last Friday. So you have a plane. Okay, if you think the plane is on the runway, so this is kind of that horizontal. But eventually, as it's running through here, it's going to take off. And then the angle that it makes with the runway, which is the horizontal that it's referencing, this angle right here is 11 degrees. Question then is, find to the nearest foot the height of the plane. So we're going to be looking for how far above the ground is this. And when we do that, we create a nice right angle, which is important for any of this right triangle trig stuff. You obviously have to have a right angle. We're going to look for this height, so that's the answer to the question. So we'll call that our x. After it has traveled a horizontal distance of 1,000 feet. So that's important. The one we did with the airplane, it was asking you for this distance right here. This would not be its horizontal distance, however. So in this case, the horizontal distance is the distance here. And then that is 1,000 feet. And then with all of these, so the quiz tomorrow, pretty much every problem is a SOHCAHTOA idea. All these little word problems. You have to then determine if this is your reference angle, which it is. What two sides are we given? The opposites, the adjacents, or the hypotenuse? And then based upon that, we pick our function. All right, so Cam, what do we got working?
We have the adjacent and the opposite.
Good. Good. So this is the adjacent side here to this angle. And then this side over here is the opposite side. And then he said, because of that, opposite and the adjacent, we have to go with the tangent function. So you're going to set up the tangent of that 11-degree angle is equal to the opposite side over the adjacent side. And then again, last chance before tomorrow, you got to do a bunch of these on your own with your calculator to make sure that we know how to plug these in. All right, this is the one that's probably the nicest to plug in, where we're going to multiply both sides. If we try to get that x by itself, we're going to multiply both sides by 1,000. Make sure your calculator is in the correct mode tomorrow before you start. And then this is what we are plugging into your calculator, especially if you loan your calculator out to somebody during the day, or I wouldn't know any other class you would change it to radians that you would be in right now. So just make sure you're in degrees. All right, what's that give us?
194.38.
All right, do we all agree with that? Okay. Just checking. I can plug them in, but it's kind of a pain in the butt on the computer calculator. It takes a little while. These we're going to want to throw some units on because the units are important, and this should be feet. All right, so a little more than 194 feet above the ground at that time. All right. Go to that. Okay. Next one. I want to make sure we get to some of the triangles at the beginning. And another topic I want to make sure we get to. Let's go every other one for now. All right, let's go number 5. we'll do the odds. I'll leave you guys the evens if you want some points for tomorrow. So it says, number 5, a ladder 30 feet long leans against the building and makes a 72-degree angle with the ground. Find to the nearest foot how high on the building the ladder reaches. So take a minute before I draw anything. We're hopefully at a point where we can largely draw these. This is the homework that's due tonight. These are just kind of more of the same. So see where we're at. Go ahead, give you a minute or two, set that up, set up your equation, see if you can solve it, and then we'll see where we're at here in a minute or two. Okay, then as you're finishing, then you can just kind of see if you did this correctly or not. And if you did, feel good about yourself. If you did not, just pay good attention when we go over this and see where maybe you would have gone wrong. All right, I'm getting that. Good. All right. If you don't get that 28.5 feet, then just as we're going through it, kind of see where maybe that breakdown would have been. Was it your picture? Was it setting up the equation, or did you solve the equation incorrectly? Yeah, I should get that. All right, so here we go. So this is our building. And then you had a ladder leaning against it. So if this is our ladder right here, then this is where you should assign the 30 feet. So our ladder is 30 feet long. It's leaning against the building, and it's making a 72-degree angle with the ground. So if this is our ladder and this is the ground, it is this angle right here. That should have been our 72-degree angle. Then the question, how high on the building the ladder reaches. So here is the ladder. How high up on, so the building could be taller, but how high up on that building does the ladder reach? So the building here is the variable that we are solving for. Okay. With a good picture then, now it's just a matter of our SOHCAHTOA ideas. If this is our angle that we're concerned about, this is what we would call our reference angle. We're basing everything off of this angle. This is the opposite side. This is the hypotenuse. So the opposite and the hypotenuse is the sine, right? We know the angle. It's a 72-degree angle. The opposite side was the x, and then the hypotenuse was 30. Multiply both sides by 30. And then that should give you this 28.53 feet, right? All right, good with that? All right. Jump to number 7 then. Set that one up. So see if you can draw this picture. Again, tomorrow to do these, you really need a quality picture, or else you're going to have a problem. Certainly some of them I'll probably give you a triangle. That's the beginning of 6.9. Before we had word problems, I just gave you the triangle, and then you can just look at it. But then now the last few days of 6.9 are the word problems. You need to come up with your own triangle based upon the little story that you're going to read. Okay, you're starting to get close. Here is our answer. So if you get this, again, good. This one's a little different, right? We did these obviously last week, but the first one today when we start talking about an angle of depression. So that's a little bit different. That's the angle we look down at. So a little different little setup here. Got to remember kind of how we did those. But you should get about 188 feet. Are we close? Machine. Okay, I'm not so sure.
I was sitting in the business last year, so I was trying to go back and see how to do altitude.
Altitude implies up and down.
Okay.
All right, like if you get on a plane, eventually the pilot says we've reached our cruising altitude. It basically means we've reached the height at which now we're not going to climb anymore. We're just going to hang tight.
Oh, okay.
So altitude deals with the idea of up and down. Okay. Yeah. So, all right. Let's see where we're at with all of this then. So it says an artillery spotter in a plane at an altitude. So there was a question here. So maybe at home, maybe it's not something that we just know. Altitude implies vertical. Right? How far up and down do we go? So when a plane reaches its cruising altitude, it's basically saying its height. So when we start talking about this plane at an altitude of 1,000 feet, what that means is, I'm not going to try to draw a plane. Someone's going to write the word in. Here's our plane, and it is 1,000 feet above the ground. All right, so that's our plane. It's 1,000 feet above the ground. Here's our ground. And then you have a tank. So I'm not going to try to draw a tank, so we'll just write the word tank. That it observes, then you are told this as well, an angle of depression of the enemy tank is 28 degrees. So what we talked about when we did these is the angle of depression is always made with the horizontal. So what that would mean is if this plane, if you're on the plane or you're the pilot and it's looking straight out, why is my pen not working? Then that's your horizontal. So right here, maybe. Come on, you can do it. There we go. So that's our horizontal right here. So the angle has to be made with this as part of the angle. And then if we're now actually looking down at this tank, those are the two lines that make our angle, the horizontal line and the angle at which we're looking down. So it is this angle right here that we consider the angle of depression. So the 28 degrees that you're given is that angle there. But then what we talked about is our right triangle is down here. This 28-degree angle that I just marked isn't even in our triangle. So for us to use that, we need to somehow figure out how can we get an angle within our triangle. So what we've always talked about is this is a horizontal line, as is this here. That angle that I have marked 28 is the alternate interior angle of this angle within the triangle. So that angle then has to be a 28-degree angle as well. All right. Then the question asks, how far to the nearest foot? I guess I don't, now that I read this closely, the answer is just 188 because we don't want anything. We want it to be the nearest foot, no decimals. Is the enemy tank, so here's our tank, from the point on the ground directly below the spotter. So that would be this point right here is directly below the plane. We're looking for that length right there, from the tank to that spot directly below. Yeah. I think you might be right. Now that I look at this. Yeah, because this should be what function, Ahmed? Did I mess it up?
Well, since you divide by, it should be like a
20 tangent.
No, it should be.
Yeah, I did 100, so it's off by 1 decimal as I'm looking at it. Yeah, so we'll fix that in a minute. What should our equation be though then, Ahmed?
supposed to be 1,000 divided by, not 1,000.
Give me the whole equation here.
Okay.
Like what function?
Tangent, I use 1,000 divided by the tangent of 28.
Good. So initially it's the tangent, because if this is our reference angle, this is the opposite side over the adjacent side. So the opposite side is 1,000. And then the adjacent side is the x. Yeah, I'm going to be off by 1 decimal here because I have 100 written on my paper over here. Then this equation, a little bit harder to solve. We've solved these enough though that hopefully this isn't a big deal. We don't want the x in the denominator, so you're going to multiply that over. Then to get the x by itself, we need to divide that tangent of 28 over. So let me do that over here. So the answer to this is 1,000 divided by the tangent of 28. And then I put 100 in, as I see on my paper. So we should have one more zero here, right? Is it 1,880?
Yeah.
Yeah. And then that should be feet. Right. So that's an angle of depression. This is your horizontal here. This is a horizontal here. These are alternate interior. You could also, I thought about this last week, and now that I have this here, couldn't this also, doesn't this full angle equal 90 degrees? So we could, if we know this full angle is 90 and we have 28, couldn't I also do 90 minus 28 and get this to be a 62 degree angle? And then I don't need this one. And then we could set up with this angle and those two sides. So that's an option. But I think alternate interiors are the kind of the easiest, the one that we deal with. So that's what we usually go with.
We're used to that one.
Yeah. All right. So now let's go to number 9. So we'll do 9. We'll do the odds and I'll leave you the evens. Number 9 says in a triangle A, B, C, angle C is a 90 degree angle. So I'll draw a triangle. Make sure it's a 90 degree triangle because you're told one of the angles has a 90 degree angle. So this is going to be my 90 degree angle right here. That must be side C, or angle C. The A and the B don't matter where you put them. I'm going to put A right here, and I'm going to put B right here. We then know that angle A is 42 degrees. Notice how it now asks for little b. So probably the first time we've actually have done this. When we have a right triangle, so you don't just have to redraw this. If this is A, this is B, and this is our C. Notice how here is angle A. The opposite side If this is big angle A, the opposite side would be the same letter. We just write it as a little a. If this is capital B as the angle, the side that's opposite of angle B would be side B. We just write it as a little b. And then here's angle C. The opposite side of that is here. We would call this little c. So in this question, if it's asking you for little b, write down where little b has to go on this triangle. All right, then what we hopefully did, if this is big angle B, little b is the side opposite of this. That's the answer to the question. This is what we're going to try to solve for. And then you were told that little c is 110. So if this is our angle C, little c should be the side opposite of that. All right, we got that. We see that in the future. Number 10 will be the same thing. Now we answer the question. Now set up one that's going to allow us to figure out what angle B is, or side B is. So we're ultimately looking for this length right here. How long is this side? All right, let's see what our setup is. Here's our angle we know. So here's your reference angle that I have highlighted in yellow. So then look at the side that we need and the side that we know. The side that we need isn't the side we need, the adjacent side. And the side that we know isn't this, your hypotenuse. So if this is the adjacent and the hypotenuse, first time today we've done this, this is your cosine function. Right? Cosine is the adjacent over the hypotenuse. So the angle is a 42-degree angle. The adjacent side of this 42-degree angle is B. The hypotenuse of that is 110. And then our nicest equation to solve, just multiply that 110 over. I don't know if my pen's going to make it through the day here. Here we go. Okay, I don't have time. What do we get for that? 31? 81.75. All right, we all get that? We all agree? All right, and then there are no units, so that's our answer. So 10 will be the same thing. You wanted to try that one. And then the last two. All right, here's this, so we're still writing. All right, number 11. 11 and 12, they're different shapes, so we'll see what you can do with number 12. But number 11 we'll do now. So the lengths of two sides of a parallelogram are 6 inches and 10 inches. So let's draw that in first. Remember what a parallelogram is, a basic parallelogram. So don't draw in a rectangle, even though that is a parallelogram. Don't draw in a square because that is a parallelogram. If we wanted those, we would use those words. So a regular old parallelogram without any special unique properties looks like this. At least if I was a good drawer. That's okay. As long, what has to be true is the opposite sides need to be congruent and they need to be parallel. Do you still have that? Okay, then that's not a parallelogram. I think you may have drawn a trapezoid. All right. Okay. So let's label these then. This is 6. The shorter side would have to be 6 inches. The longer side is going to have to be 10. And then opposite sides are congruent. So then we know both of the longer sides are 10. Both of the shorter sides are going to be 10. And then the angle between those two sides measures 41 degrees. So I'm going to use this 6 and this 10 and the angle between those two sides right here. this angle has to be 41 degrees. So put your 41 right there. Okay. When this says what is the length, remember altitude implies kind of that vertical up and down distance, all right, on the longer side. So the way we can produce that is if I go to this vertex point right here where these two sides meet and I drop down, remember we talked about the word altitude, and we go down to the longer side here, notice how we're creating a nice 90-degree angle here. That also means we have a 90-degree angle over here. The question is then just asking you for this length here. So that is your X. So if we just focus in on this yellow, this little triangle off to the left, once you have the drawing, then hopefully this is nice. If this is your angle, here's our 90-degree angle here. So if this is our angle here, I have the opposite side and the hypotenuse. So this would be the sine of 41 degrees is equal to the opposite side, which is your X, over the hypotenuse, which is 6. Wish I would have given them one with, had to find the angle because none of them had this today. Maybe we'll make one of those up for tomorrow real quick. All right, so plug that in. Sine of 6 times the sine of 41. 3.94 seems reasonable. And then that, since we're talking lengths now, it does give us inches and such. We'll label that with inches. All right. So one, it's a nice review to see if you can do these. All right, and then it is also an opportunity as we get close to the end of the semester, if you want a little extra credit, you're going to turn in all 12 of those tomorrow night. And again, that's going to be right here. If you haven't done today's, here's today's date. Make sure that gets uploaded by midnight. And if you wanted to finish off these problems, submit those by tomorrow night. And if you have any questions, let us know. All right, but we'll do a little quiz tomorrow. I'm probably going to maybe half a dozen questions. They take long enough anyway. And then just make sure you have your calculator ready. Make sure you know how to plug these in. Last week when we gave you the little exit quiz, and then the day that we weren't here on Wednesday, there were a lot of calculator issues, people not knowing how to plug these in. And if you haven't figured that out, make sure you somehow between now and tomorrow reach out to me or Mr. Kubowitz and figure out how we can do that or find someone who can help you. All right. Okay, if you were at home, we are done, so you guys can check on out. We'll see you tomorrow. And yeah, that's a wrap.